after that. Okay. Okay, our revision class charts. The chapter is light, reflection, and refraction. Now, first, what is light? Light is a form of energy which causes the sensation of vision when light reflected back from the object. Okay, that's light. What is light? Light is a form of energy which causes the sensation of vision and which makes the object visible when reflected from it. Okay, you know that. And there is some theories of light, not so important. Not so important. Then reflection, very important. You have to understand what is reflection. What is reflection? Bouncing back of light from a surface when it hit on that surface, right? When it hit on that surface. Okay, reflection. Bouncing back of light from a surface, right? What is reflection? Bouncing off a light ray. Bouncing off of light ray from a surface is called what? Reflection. Now this is the figure for reflection, and you can see this is incident ray. What is this ray? Incident ray. What is incident ray? The ray that is coming towards the surface. The ray that is coming, that's incident ray. And what is this? Reflected ray. What is that ray? That's a reflected ray. Reflected ray. And you can draw a line perpendicular to the surface. What is the line perpendicular to the surface called? Normal. That's normal. And there is an angle, incidence angle. Angle of incidence. And this is what? Angle of refraction. Angle of incidence and angle of refraction. And we saw what is, angle of reflection. And what is loss of reflection? Loss of reflection. What was loss of reflection? First one. Incident ray. Normal. Reflected ray. All lying in the same way. And second one. Angle of incidence will be equal to angle of reflection. I is equal to R. Now the characteristics of the image formed by a plane mirror. A plane mirror. What will be the characteristics of an image formed by a plane mirror? Object size will be same. And object is what? Erect. If it is erect, that will be virtual. If it is erect, that will be virtual. And there is a name, there is a term called laterally inverted. What is that term? Laterally inverted. The term is laterally inverted. You got it? Laterally inverted. And spherical mirrors. Spherical mirrors. What was spherical mirrors? Yeah, spherical mirrors. This is a flat mirror. What was spherical mirrors? If the reflecting surface is a part of the sphere, that type of mirror is called what? Spherical mirrors, right? If the reflecting surface is part of a sphere, right, Jonathan?
Hi, sir.
Hi. Okay, if the reflecting surface is part of a sphere, that type of mirror is called what? Spherical mirror. And this is what? This is convex mirror. This is concave mirror. And you can define convex and concave. What is convex mirror? Bulged outwards. If the reflecting surface is bulged outwards, then that is convex mirror. What is concave mirror? If the reflecting surface is bulged inwards, then that is what? Concave mirror. Okay. Then there were some terms associated with these spherical mirrors. What was the terms associated with the spherical mirrors? What was the terms associated with those spherical mirrors? What is the first term? Pole. What was pole? A pole is the center of the mirror. Then center of curvature. What was center of curvature? Center of the sphere of which the spherical mirror is a part. Then there is principal axis. What is that? Imaginary line passing through pole and center of curvature. That's what? Principal axis. That's principal axis. And then radius of curvature. What is radius of curvature? Radius of the sphere. Okay. Radius of the sphere of which the spherical mirror is a part, or the distance from the distance from the pole to the center of curvature. To the center of curvature. That is what? That is radius of curvature. You know that. And principal focus. Principal focus of a convex mirror and a concave mirror. If you are talking about a concave mirror, what will be the principal focus? Like what is happening here? The parallel lines to this principal axis, right? The light rays parallel to the principal axis after reflection passes through a point on the principal axis called principal focus. That is principal focus of a concave mirror, right? That's principal focus of a concave mirror. It will be like this. Okay. Then what is principal focus of a convex mirror? Principal focus of a convex mirror. You can use the same idea to explain that also. What is that? The light rays coming parallel to the principal axis of a convex mirror after reflection appears to coming from a point on the principal axis. That point is called what? Principal focus. Then what is focal length? What is focal length? Focal length is the distance from the pole to the principal focus. Distance from the pole to the principal focus of a lens. Mirror. Yeah? Then what is aperture? Aperture. What was aperture? Yes, aperture is the circular diameter. Diameter of the circular outline of a spherical mirror. Reflecting surface of a spherical mirror. That's aperture. What is that? Aperture. Give me the definition for aperture once again. What is aperture? The diameter of the circular outline of reflecting surface of the spherical mirror. That is aperture. Then after that, we have to see some behaviors of rays. What was first behavior of the ray that we discussed? Light rays coming parallel will pass through principal focus, right? The second one, light ray passing through principal focus will go parallel like this. Then light ray coming through, passing through C, center of curvature, will be returning through the same path. It will be returning through the same path. Then, yeah, about P. There is something about P. When a light ray is hitting on P at an angle, it will obey laws of reflection. It will obey laws of reflection. You got it? That's it. Then there was images. Formation of images. Should I repeat that? Formation of images. Huh? Do you need that formation of images? I will quickly do it. Formation of images. The first one, we are using a concave mirror. We are using a concave mirror. First one was that. First one was object at infinity. Object at infinity. Object at infinity. This is mirror, right? This is our mirror, and object is at infinity. If the object is at infinity, the light rays will be parallel to principal axis. The light rays will be parallel to principal axis. So the light rays will be coming parallel to principal axis like this. Okay, and it will converge at a point on the principal axis. That point is principal focus like this. So the image will be at F. And it is a real image because the light rays are joining here. Light rays are converging here. So that's a real image. If that's a real image, that will be inverted also. If that's a real image, that will be inverted also. So that's a real image and inverted, and it is forming at F. What about the size? Yeah, that will be a point size image. So highly diminished. Highly diminished, highly diminished. That's a point-sized image, highly diminished. Got it? Okay, then what is the second one? What is the second one? Second figure. Now the object is beyond the sea. Now the object is where? Object is beyond the sea. Beyond the sea. Object is beyond the sea. What is this beyond the sea? This is our mirror, and this is 2 centimeter at 4 centimeter. We can take 2 centimeter F and 2 centimeter C. Then that is 4 centimeter as a whole. So beyond the C will be 1 centimeter height object is placed here. Then first light ray. What will be the first light ray?
Parallel.
First light ray is parallel to principal axis. It will pass through principal focus like this. And the second light ray, you can pass the second light ray through this principal focus. That will be parallel to the principal axis like this. If the object is beyond C, the image is between where? The image is between C and F. So the image is between C and F, and it is formed by the intersection of 2 light rays. So that will be real and inverted. It will be real and inverted. Then, yeah, it can be diminished. It is diminished. It will be a diminished image. You got it? That will be a diminished image. And we got the position, nature, and size of the image. Position, nature, and size of the image. You got it? That's our second one. Object beyond the sea. Now the third one. What is the third one? Object at sea. Object at sea. This is our mirror. This is our F. This is our C. Now the object is where? The object is at sea. If the object is at sea, the first light ray is like this. It is passing through the F like this, and second light ray will be passing through F like this, and it is joining here. It is joining at a point here. It is joining at a point here. Then you will get where? You will get the image where? Where is the image? The image is at sea. The image is at sea. What is the nature of the image? It will be real and inverted. If it is real, it will be inverted. Then what? Size will be same. Size will be same. Same size of the image will be getting. And is there anything? No, that will be enough. And fourth one. What is the fourth one? Object. Now is between C and F. Now the object is between C and F. The object is between C and F means this is F, this is C. Now the object is between C and F. What will be the light ray? Light ray will be like this, right? And what will happen to that light ray? It will pass through principal focus like this. And second light ray. Second light ray is passing through principal focus, and it will converge. It will work. It will converge at a point. It will converge at a point. It will converge at a point, and you will get that point. Yeah, you will get that point beyond the sea. My calculations is not correct. That's why my image is looking like this. Okay, this is our mirror, and this is M. This is C. Okay. And where are we placing the object? We are placing the object. We are placing the object between C and F. The first light ray is like this. It is passing through the principal box like this. And the second light ray can be passing through this principal focus. And it will be converging at this point. It will be converging at this point. So you will get an image here. Huh? The image is what? The image is what? The image is beyond C. What is the image? Image is beyond C. Image is beyond C. And what can you say about the size of the image? The image size will be enlarged. The image size will be enlarged. Then it will be real and inverted. It will be real and inverted. It will be real and inverted because it is formed by the intersection of 2 light rays. So it is real and inverted. You got it? That's real and inverted. Now that's object between C and F. Now our fifth one, object at F, right? The object at F. What will happen if we are placing the object at F? If the object is at F, what will be the image? Yeah, the light ray will be like this. First light ray will be like this. Second light ray you can draw the second light ray like this. So the second light ray also is a parallel line that is compared to the first light ray. That means they will meet at infinity. So the position of the image will be at infinity. The position of the image will be at infinity. Image will be at infinity, and it will be real and inverted, because two light rays are going to infinity. They will meet at there. They will meet at there. So real and inverted image. So real and inverted image. You got it? Okay. And that will be highly enlarged. Highly enlarged. That image will be highly enlarged. Then the sixth one. What is the sixth one? Yeah. Sixth one. Object is between F and P. Now the object is between F and P. Now this is our F, this is our C. The object is now between F and P. Where is P? P is here, right? First light ray. What will happen to the first light ray? First light ray is traveling like this, and it is passing through F. Okay? And second light ray. I am drawing the second light ray like this, and it is going like this. And as you can see, they are not parallel, they are away from each other. As the distance is increasing, they will getting away and away from each other. They will not meet at infinity because they are going away from each other. They are going away from each other, right? So you cannot get an image on the left side. You will not get an image on the left side. And you can extend the light rays. You can extend the light rays. Now the light rays are joining at a point. Now the light rays are joining at a point. Light rays are joining at a point. You will get a virtual image there. You will get a virtual image there. Because the actual light rays are not joining at a point. The extensions are joining. Right? The extensions are joining at a point, that not actual light rays. Actual light rays is not joining at anywhere, so it is a virtual image. If it is a virtual image, that will be erect. If it is a virtual image, that will be an erect image also. Then that's enlarged image. Enlarged image. And what can you say about the position of the image? That will be behind the mirror. The position of the image, that will be behind the mirror. Behind the mirror. You got it? That's our sixth one. Okay? That's our sixth one. Now we have to draw two figures, two ray diagrams for concave mirror. For concave mirror. What is the first ray diagram for concave mirror? Object is at infinity. Object is at infinity. If the object is at infinity, the coming light rays will be parallel. The coming light rays will be, convex. Convex. Okay? We have to draw for convex. And coming light rays will be parallel. If the coming light rays are parallel, it will be like this. I can use two light rays, and they will appear to diverge from a point on the principal axis. That point is principal focus. So the object is at infinity. Image is at where? At principal focus. At a principal focus. And what is the size? That will be a point size of the image. That is highly diminished. Highly diminished. The image will be highly diminished. Then that will be a virtual. No light rays are joining together. Also, that is a virtual image. That's a virtual image and erect image. That's a virtual and erect image. Right? So that's our first one. And the second one, object between infinity and pole. Object can be anywhere. That's infinity and pole. So object between infinity. Object between infinity and pole. Object between infinity and pole. We need a convex mirror, and between infinity and pole means object can be anywhere like this. This is C, this is F. and first light ray is like this. This is not here. There, here is M and here is C. First light ray is like this, and it will be reflecting like this, diverging like this. Second light ray, I can draw a second light ray to the pole. I can draw a second light ray to the pole. That will what? That will follow the laws of reflection. That means the angle of incidence will be equal to angle of reflection here, and you can extend the light ray like this. If you are extending the light ray, you will get a virtual image here. You will get a virtual image here. So the image will be virtual. The image will be virtual, and that will be erect. What will be the size of the image? Size of the image will be diminished. Size of the image will be diminished. You got it? That's our figures. And after that, uses of concave mirror. What are the uses of concave mirror? Where can we use concave mirrors? Shading mirrors. Concave. We can use concave mirror as shading mirror. Then torch, searchlight, spotlight, etc. Right? Torches and searchlights. Then spotlights, yeah, spotlights, and used by dentists. Then also a simple one is the headlights, vehicle headlights, right? Vehicle, automobile, vehicle headlights. Then solar furnaces, because we need to concentrate the heat of the sun. So solar furnaces. That's concave mirror. And now convex mirror. Where can you use this convex mirror? Rear view mirror of vehicles. Rear view mirror of vehicles, because it produces erect, smaller, not large, erect, smaller, and is a wider or larger field of view. Okay, that's the use. And can you give me another use for sharp, on the sharp corners of road. Okay, then anti-theft mirrors. Then parking lots, used in parking lots. Good. Okay, then after that we studied the lens formula, sign convention, and mirror formula. What was mirror formula? Yeah, mirror formula is 1 by f is equal to 1 by v plus 1 by u. This is what? Mirror formula. You need new Cartesian sign convention. What is new Cartesian sign convention in the case of mirrors? In the case of mirrors and in the case of lenses, they are same. Okay, every measurement should be taken from pole. That's the first one. Every measurement should be taken from pole, and measurements towards right is positive, towards left is negative, upwards is positive, downwards is negative. You got it? Okay. Then where you are placing the object, you have to place the object always on the left. You have to place the object always on the left. Is there anything you have to remember? This is what actually the light rays from object will be in this direction. Light rays from the object will be towards right. So the light ray, the direction, the measurement towards the light ray will be positive. Right? Towards the light ray will be positive. Opposite of light ray will be negative. Towards positive, opposite negative. You got it? Okay, that's it. Then we studied magnification. What was magnification? Magnification can be represented with this M. What is that? How much large is the image when compared to the object? That's magnification. And it has an equation M is equal to HI divided by HO. You can use this equation to define magnification. What is magnification? It is the ratio of height of the image to the height of the object. And it has another equation also. Minus V by U in the case of mirrors. Minus V by U in the case of mirrors. Okay. So that's magnification. And what is this VU? Image distance and object distance. You know that. What is this F? That's focal length. We have seen that. This is the equation for magnification. You have to remember this equation. Okay. If magnification, magnitude of magnification is equal to 1, what is its meaning? What is its meaning? It is the same size as that of the object. Image is the same size as that of the object. If magnification is less than 1, what is the meaning of that? Image is smaller or diminished. Image is smaller or diminished. If magnification is greater than 1, the image is enlarged. Right? Okay. Then that's our idea. After that, we studied the refraction. After that, we studied the refraction. What is refraction? When light ray is traveling from one medium to another medium. When light ray travels from one medium to another medium, light ray bends. The path of the light ray bends. That is called the refraction. So the bending of light ray when it travels from one medium to another. Right? Okay. And this medium can be called air, and this medium can be called water. Okay. Now this is what? This is rarer to denser. Rarer to denser. If light ray is coming from rarer to denser, what is that? Light ray will be bent towards the normal. Bend towards the normal. And if light ray, this is water and air. So if the light ray is coming from denser to rarer, it is bending away from normal. It is bending away from normal. This is normal. Bending away from normal. You got it? Okay. Now we have to see the laws of refraction. Laws of refraction. What are the laws of refraction? Two of them are the first is very simple: incident ray, normal, refracted ray, all lie on the same plane. That's the first one. Second one, you can say the second one with this equation: sin n by sin r is equal to a constant. What is that? A constant. A constant. Now convert that into words. What is that? Ratio of sin of angle of incidence. Sin of angle of incidence to the side of angle of refraction is a constant. Okay, and that constant has a name. That constant can be written like this. This is N21. What is that constant? That's N21. What is N21? Refractive index of second medium with respect to first medium. What is N21? N21 is refractive index of second medium with respect to first medium. Got it? Then what is this refractive index? What is this refractive index? Refractive index. Refractive index is a number C by B. That's a number C by B. What is C? Speed of light in vacuum. Speed of light in vacuum. That's C. And what is B? Speed of light in medium. Speed of light in medium. So what is refractive index? Ratio of speed of light in vacuum to the speed of light in medium is called the N, refractive index. It has another name, absolute refractive index. What is another name for that? Absolute refractive index. Okay, got it? So that's refractive index. And this is first medium. First medium will have a refractive index N1. First medium will have a refractive index N1. You got it? First medium has a refractive index N1. Now, this is second medium. Second medium has a refractive index N2. Second medium has a refractive index N2. Second medium has a refractive index N2. You got it? Okay. Then what is N21? N21 will be N2 divided by N1. Refractive index of second medium divided by refractive index of first medium. That is N21. Okay, that is N21, and it is also equal to. I am taking the velocity of light, the speed of light in this medium as v1 and second medium as v2. Okay, velocity of light in first medium as v1 and second medium as v2. Then n21 is equal to n2 by n1. Also, it will be v1 by v2. This is the equation for n21. Then what will be the equation of n12? Yes, n12 will be n1 by n2 and v2 by v1. v2 by v1. Right? After this, we studied lateral displacement, right? We studied lateral displacement. What was lateral displacement? Lateral displacement. Yes, this is a glass slab. If this is a glass slab, light ray will be coming like this, obliquely hitting on the glass slab. This is what? This is glass slab. This is air. Okay, and you can draw. What is this? A normal. That's a normal. I'm taking it as N1, and this is the actual position, actual path of the light ray, and it will bend it towards the normal like this, and it is supposed to go like this, but there will be a normal like this. That normal I am taking it as N2, and it will be coming from glass to air again. If it is coming from glass to air, then that will bend away from the normal. And now you can see the emergent ray. This is the emergent ray. This is the incident ray. This is the refracted ray. This is the emergent ray. And emergent ray. And what is this? This is the original path of incident ray. Incident ray. Original path of incident ray. And they are having a perpendicular distance. That perpendicular distance is called lateral displacement. That perpendicular distance is called what? Lateral displacement, and it is depending upon the width of the glass, right? Thickness of the glass, and what is that? Refractive index of the glass slab and angle of incidence. Refractive index of the glass slab and angle of incidence. Then we studied refraction through spherical surfaces. Spherical surfaces. So we studied the lenses. What was lenses? A transparent medium made of what is lenses? What is lenses? What are lenses? It's a transparent medium bounded by two spherical surfaces. Two spherical surfaces. Bounded by two surfaces, one of them may be spherical. One of them can be spherical. That is what? Lens. And there was convex lens and concave lens. Convex lens and concave lens. There was convex lens and concave lens. And what was convex lens? What was convex lens? If the refracting. This is the refraction. If the refracting surface is bulged outward, that is convex lens. And if the refracting surfaces are curved inward, that is concave lens. And there was some terms associated with it. What was the terms? The first term. What is the first term? Optical center. First term is optical center. Center of the geometrical center of the lens. That's optic center. Then there was F2F1. What is 2F1? Center of curvature. What is center of curvature? Center of curvature is the center of the sphere of by which the lens is made. The sphere, there is a sphere of which the lens is emerged. Okay. So the center of the sphere by which the mirror is made. The center of the sphere by which the mirror is made. That's center of curvature. And you have this F. You have this F. What is this F? Focal length. Focal length. What will be the focal length of a convex mirror? Focal length of a convex mirror will be the light rays coming parallel to the principal axis. After refraction will pass through a point on the principal axis. That is called the principal focus. Okay. And what about this concave lens? What about the concave lens? The light rays coming parallel to the principal axis will diverge from a point on the principal axis on the same side of the lens. Diverge from a point. That point is called the principal focus of a concave lens. Principal focus of a concave lens. You got it? Then after that, we studied aperture also. Aperture has the same meaning and same definition. Okay. Then behavior of some rays. What was the behavior of some rays? This is a convex lens, and the light rays will be passing through principal focus like this. And if the light rays are coming through principal focus, it will be after reflection, it will be going parallel like this. And if light rays are passing through the center of curvature, it will not deviate. It will not deviate. So. Okay, if the light rays are coming passing through optic center, and it will not deviate. It will not deviate. And then anything else? Then anything else? That's enough. That's enough idea to draw a ray diagram. That's enough idea to draw a ray diagram. Then we have to see some ray diagrams. 6 cases in convex lens, 2 cases in concave lens. What was the first case in convex lens? The object is at infinity. The object is at infinity. If the object is at infinity, the light rays will be parallel, and that will converge at a point on the principal axis. So the object is at F. So the image is at F, and it is real and inverted. It will be real and inverted. Anything else? It is real and inverted. It will be point size or highly diminished. Highly diminished. Now the second one. Give me the second one. What is the second one? Now the object beyond 2f1. The C is called 2f1, right? Okay. So this is f1. This is 2f1. Now the object is here. First light ray is like this. It is refracting and passes through the principal focus like this. Okay, that's f2. That's f2. Now the second light ray is coming towards the optical center, and it will be going like this, and you will get an image like this. That image will be beyond, between f2 and 2f2. So the image will be between 2f2 and f2, and it will be real and inverted and diminished. Real and inverted and diminished. Okay, and the third one. Now the object is at 2f1. If the object is at 2f1, this is f1, this is 2f1, object is at 2f1, first light ray will be like this, second one, that's f2, second one will be through the optical center, and it will be like this. And the image will be formed at 2f2. Image will be formed at 2f2. It will be real and inverted. It is same size as that of the object. Okay, same size as that of the object. And the fourth one. Now the object is between 2f1 and f1. If the object is between 2f1 and f1, this is f1, this is 2f1. Now the object is between 2f1 and f1. This is the first light ray passing through principal focus like this. This is optic center passing through like this. Optic center passing through like this. So it will be beyond 2f2. Beyond 2f2. The image will be beyond 2f2, and it will be enlarged, and it will be real and inverted. So the fifth one. What is the fifth one? Now the object is at f1. Now the object is at f1. If the object is at f1, this is f1, this is 2f1. If the object is at f1, first light ray is like this. It will pass through f2 like this. It will pass through f2 like this. And second light ray is passing through optical center. Now they will be parallel. Parallel light rays will meet at infinity. So the image is at infinity, and it will be real, inverted, highly enlarged. Real, inverted, highly enlarged. Then the sixth one. We are placing between f1 and optic center. So the object is here and it is first light ray is passing like this. This is F2. Second light ray is passing like this. This is going away from each other. They will not meet at the right side of the lens. So you can extend the light rays like this. If you are extending the light rays, they will meet at a point and you will get an image there. That image will be virtual and erect and as the same side as that of the object. Virtual, erected, same size, so same side as that of the object, it will be enlarged. It will be enlarged. So that's six figures for convex lens. Now we have to see concave lens. We have to see concave lens. What was concave lens? Two figures are there. First object is at infinity. If the object is at infinity, light rays will be coming parallel to principal axis. They will get diverged like this, and you can extend the light rays like this. This is what? This is principal focus. The object is at the principal focus and it is point sized, highly diminished. It will be virtual and erected. You can have that ideas from that figure. And the second figure, now the object is between optical center and infinity. Anywhere between optical center and infinity. So this is your lens and this is your principal axis. This is F1. This is 2F1. Now the object is between infinity and optical center. Anywhere between infinity and optical center, this is the first light ray. It will get diverged like this, and the second light ray is passing through this optical center. So you will get a very diminished image there, right? A very diminished image between F1 and O. That will be real. Sorry, that will be virtual and erect. That will be diminished. The image will be diminished. After that, we studied the applications of lenses. What are the applications of convex lenses? As magnifying glasses, right? As magnifying glasses, and to cure hypermetropia or long-sightedness, or long-sightedness. Then anything else, and camera, microscope, etc. And what about concave lens? Concave lens. Myopia. What is that word? That word is myopia or short-sightedness. Myopia or short-sightedness or near-sightedness. That is what concave lenses are used for, right? Concave lenses. In telescopes also. Okay, and used in peepholes, which is fixed on a door. Okay, which is fixed on a door. Peepholes. Got it? These are the uses of or the application of convex lens and concave lens. After that, we saw lens formula. What was lens formula? What was that? Lens formula is 1 by f is equal to 1 by v minus 1 by u. What is f? F is focal length, v is image distance, u is object distance. We know that. And after that, there is magnification. What is the equation for magnification? Just v by u. And magnification has another equation also. Hi divided by ho. All the properties of magnification are actually similar. Then the last topic was power of a lens. What is the power of a lens? The ability of the lens to converge or diverge light rays. That's the power of lens. And you can define power of lens with the equation P is equal to 1 by f if f is in meter. Okay? And P is equal to 100 divided by f if f is in centimeter. Got it? This is the power of lens. Okay? It has a unit called diopter. 1 diopter is 1 meter inverse. 1 diopter is 1 meter inverse. What is 1 diopter? It is the power of a lens having 1 meter focal length. Power of a lens having 1 meter focal length. You got it? That's our 1 diopter. Now the combination of lenses. If we are combining lenses having power P1 and P2, the combination will have a combined power. That combined power can be seen with this equation P1 plus P2. That's P1 plus P2. Now, that will be P1 plus P2. You got it? We have completed the revision of our first chapter. Every topics we have discussed every topics with just 45 minutes. By taking just exactly just 45 minutes, we have discussed every topic that's in the first chapter. Right? You just need that much time. That will be enough for us to revise it. Now we have revised it. You have every equation with you, every concept with you, every point to be remembered that's now with you. Now we will look at maximum questions from now. Okay? Okay. Then take your study material. Take your Excel study material. Jonathan, please take your Excel study material.
Yes, sir.
Your Excel study material, and we don't have time to write the questions. We don't have time to write the questions, so I will ask you to write the questions as a home assignment. We'll do the questions and numericals here. We will do the numericals from here, right? So you write page number 21. Page number 21. Page number 21. We are looking at larger questions. Page number 21. How much questions did we discuss in the class? What are the question number? Which is the question number of the last question that we have discussed in the last previous our previous class? Which is the question number we have discussed for the last 93. Did we discuss 93? Did we complete it? Did we write the answer? We got the answer? Okay, good. Can you give me a pen? I have to mark the question. So we have discussed 90, 91, 92 and 93, right?
Yes, sir.
Okay, good. Then look at the next question 94. Look at the next question 94, guys. Look at the next question 94. 94. Look at question number 94. 94. Read the question. Read the question. Give some space to write the question on your notebook. Give some space to write the question on your notebook. Writing the question is very important. You have to understand the question, identify the problem. That's very important. So we are discussing on question number 94. That will be page number 22. That will be page number 22. So we are discussing on question number 94. Question number 94. Do you have the solution booklet with you? Krita, do you have solution booklet? I need that to check the correct answer. Our method will be different. Okay, then read the question number 94, and try to answer it. I will give you some time. Read the question and try to answer it. Read the question and try to answer it. Question number 94. Question number 94. Question number 94. Try to answer it. Yeah. Question number 94. Did you at least understand the question? Did you understand the question? Understanding or identifying the question is very important. Very important. I will read the question. Read it with me. The refractive index of medium X with respect to medium Y is 2/3. What are they saying in that question? They are giving the refractive index of medium X with respect to medium Y. Okay. So I can roughly draw a figure. This is medium X, this is medium Y. Okay. And refractive index of medium X can be taken as nx, right? Medium Y, refractive index can be taken as ny. Okay. And what have they given us? Refractive index of medium X with respect to medium Y. With what letter can you specify that? With what letter, with what notification you can mark that data, given data? What is this one? N21. What is N21? That is refractive index of second medium with respect to first medium, right? So that will be N2 divided by N1, right? And it is given refractive index of X with respect to Y. Refractive index of X with respect to Y. So that you can write like this: refractive index of X with respect to Y, like this. NXY. That is given in the question. Did you understand that? It is given in the question: refractive index of medium X with respect to medium Y. That's NXY. That's NXY. If they are saying it like this, refractive index of medium Y with respect to medium X, what will be that? Ny by X. It will be Ny by X. And it is given in the question, what is the value? 2 by 3. What is that value? 2 by 3. Okay. Now, the refractive index of medium Y with respect to medium Z is 4 by 3. Right? And there is another set of media, that's Y and Z. Refractive index of Y can be called Ny, refractive index of Z can be called Nz. Now, the next data, what is the next data? Refractive index of Y with respect to Z. What is that notification? What is that notification? Yes, that will be N by Z. What is N by Z in the question? 4 by 3. What is N by Z? 4 by 3. Okay. Okay. If the speed of light in medium X is 3 into 10 raised to 8 meter per second, medium X speed of light is given. You can take it as Vx. What is Vx? That's 3 into 10 raised to 8. Vx is 3 into 10 raised to 8 meter per second. You got it? Okay. Calculate speed of light in medium Y. Medium Y, you can take the speed of light as Vy. What is the value of Vy is the question. How can you find this? How can you find this? What is the equation you are going to use? We are going to use this equation. N21 is equal to N2 by N1 is equal to V1 by V2. This is our equation. Okay, this is our equation. And you can write the same equation with this idea. Nxy is what? Nxy is what? Nxy is also equal to Nx by Ny. Nxy is what? Nx by Ny, right? And Nyz is what? Nyz is what? Nyz is Ny divided by Nz. So Nyz also is given in the question. It is given in the question. Now you have to see what? Vy. We have to see what? Vy. Nxy is equal to Nx by Ny, and it is also equal to Vy by Vx, right? Vy by Vx. We have what? We have this one. Nx by Ny is we have that. Or Vy by Vx. Vy by Vx. We have that. What is Vy by Vx? That's 2 by 3. Vy by Vx is what? 2 by 3. You got it. That's 2 by 3. If you know Vx, you can find the value of Vy. Right? This is what? This is Vy by Vx. Vy by Vx is also equal to Nxy. Nxy is equal to Nx by Ny. So Vy by Vx will be exactly equal to this 2 by 3. So Vy by Vx is 2 by 3. Got it? And what do you need to find? Vy. How can you find Vy? Bring this Nx to the other side. You will get what? This is divided by Vx. This is divided by Vx. If you are bringing that to the other side, that will be multiplied, right? Multiplied by Vx. So Vx into 2 by 3. Vx into 2 by 3. Now what is the value of Vx? Vx is 3 into 10 raised to 8 into 2 by 3. What will happen now? What will happen now in the calculation? The 3 will be cut because there is a 3 on top, there is a 3 on bottom. So top 3 and bottom 3 can be cut. Top 3 and bottom 3 can be cut. Now what are you left with? Yeah, what are you left with? You are left with the Vy is equal to, there is only a 2 and there is a 10 raised to 8. So that's 2 into 10 raised to 8 meter per second. You got it? That's the velocity in Y. That's the velocity in Y. You got it from the first point itself. You got it from the first point itself. That's the first part of the question. And now look at the second part. If the speed of light in medium x is 3 into 10 raised to 8 meter per second, calculate the speed of light in medium y. That's the only question, right? Then why did they give us this 4 by 3 medium? Why this data? Why this data? There is also find the refractive index of medium z with respect to medium x. I didn't see that. We have to find a refractive index of medium z with respect to medium x. With what letter can you represent that? With what letter can you represent that? Refractive index of medium z with respect to x. Refractive index of medium z with respect to x. That's nzx. That is nzx. Got it? That's nzx. What will be nzx? Nz divided by nx. What is nzx? Nz divided by nx. Do you have nz by nx? Do you have nz by nx? No, we don't have. We don't have nz by nx, right? But we have nxy and nyz. We have nxy and nyz. What is this nz by nx? Where we can find this nz by nx? With what operation we can find this nz by nx? You have nx by ny here, okay? And also you have ny and ny by nz here. You can do anything. And you have to find the equation for nz by nx. Do you have any idea how to find that? Any idea? I will tell you. I will tell you. I have nxy and nyz, right? I am taking this as equation 1 or equation 2. That's nxy and nyz. What if I am multiplying the first equation and the second equation? I am multiplying nxy. I am nxy multiplying nxy into nyz. Nyz. What will be that? What will be that? Multiply the equations. If I am multiplying the equation, that's nx by ny into ny by nz. What you will get on the right side of the equation? What you will get on the right side of the equation? What will happen on the right side?
Nx by nz.
Yes, there is a ny on top, ny on bottom, so that ny will be gone. You can cut that ny. There is an ny on top, ny on bottom. You can cut that ny. Got it? Okay, then you are left with the nx on top into 1 by nz. What is that? Nx by nz. What is that? Nx by nz. That's what you have to find. That's what you have to find. You have to find nz by nx. You have to find nz by nx. You got nx by nz. Take the reciprocal. That will be nz by nx. Okay, so what is this nxy? What is the nxy? That's 2 by 3, right? That is 2 by 3. So I am taking the value 2 by 3 into what is n by z? That's 4 by 3. That's 4 by 3. 4 by 3. Now this is what? This is nx by nz, right? 2 into 4. What is that? 8. divided by 3 into 3, 9. Then that is what? Nx by nz. Do we need nx by nz? No, we need nz by nx. Nz by nx. If you want nz by nx, take the reciprocal. Take the reciprocal. Take reciprocal. Take reciprocal. If you are taking the reciprocal, you will get nz by nx. What is nz by nx? Take the reciprocal. 9 will be coming here, 8 will be coming here. Then that will be 9 by 8. Got it? That's nz by nx. That is nz by nx. So this model of exams, this model of questions can be asked. They are important. This type of questions can be asked about this refractive index, and this type of question is very important to understand. Got it? So very simple. The idea is very simple. They will give you two sets of media. They will give you two sets of media. From that, you can find nxy and nyz. They most probably will be asking nzx or nxz. You can simply multiply them. If you are multiplying them, you will get either nzx or nxz. You will get it. This is actually a simple method. This is actually a simple method. If you are doing more questions by this model, you will be okay with that. Right? No. Do you in your schools did you do such type of questions? If you haven't done it in school, then the type of questions will not be coming in this. Right? But this is actually a previous question. It's actually a previously asked question. This can be coming in the board exam. So you have to understand how to do that. Okay? Write this question. And after that, you can take a small break. Take a 5-minute break, and after that, we will continue. If there is any problems with any confusion with any topics, you can ask me. Sorry, any steps, you can ask me. Jonathan, did you understand the question?
Yes, sir.
Okay. There is actually two-part question, two part of the questions that we have discussed so far. The first part is to find the Vy, velocity of light in Y. We have to find velocity of light in Y, or speed of light in Y. How can we find the velocity of light in Y? With this equation, nxy is nx by ny. That will be ny by vy by vx. So you can use vy by vx as 2 by 3. From that, vx is already given, so you can find vy. So you can easily find vy. That's the simplest part. Okay. And in the next part of the question, they are asking for nzx. Nzx is nz by nx. How can you find this nz by nx? Just multiply the nxy and the nyz. You will understand that. You will get it. When you are multiplying nxy and nyz, this ny is gone. That will be nx by nz, and nx by nz has a value. By multiplying it, you will get a value. Okay. Then take the reciprocal, you will get nz by nx. Take the reciprocal, you will get nz by nx. If you have completed the note, you can take a 5-minute break. And make it fast. I will be here. When you all are here, we will continue. Mark that question as done. Okay, mark that question as done. Did you understand it? Or what about David? Sarah? Understand? Have to write a question now. You don't have to write a question right now. You just give some space to write a question, then answer it. You don't have that much time left. Take a small break. When you all are here, okay? Can you take a break? Then that's last today. Sarah has class till 8:30 or 9. It's 9. Yeah, so you will be waiting for the for the until then. Okay. We can continue, right? Right? Okay. Then look at 95. Question number 95. Question number 95. Question number 95. Look at question number 95. Question number 95. You don't have to write the question. You don't have to write the question. Just question number 95. Read it. Study the ray diagram given below and answer the questions that follows. Is the type of lens used converging or diverging? What is the answer? What is that type of lens? Converging. That's a convex lens. So that will be converging. So the type of lens is converging. You got it? Type of lens is converging. Then B. Question number B. List 3 characteristics of the image formed. What will be the characteristics of image? You can see the characteristics from the figure itself. It is real, right? And inverted. If it is real, that will be inverted. Now, the object is between 2f1 and f1. So the image is beyond 2f2. If the image is beyond 2f2, that will be enlarged. The image is beyond 2f2, that will be enlarged. So the image will be enlarged. You got it. Image is enlarged. And where is the position of the image? Position. You can write the position also. Position is beyond 2f2. Position is beyond 2f2. Now, in which position of the object will the magnification be -1? Where you will get magnification as -1? Where is the position of the image for this magnification? When you will get this magnification? This magnification means negative, means it is real. It is real. And 1 means same size as that of the object. So where you have to place the object? At C or at 2f1. Okay, at 2f1. So the object will be at 2f1. You can answer it very simply. This question is very simple, right? That question is very simple. Then read the next question, 96. Read the next question, 96. Read the next question, 96. How fat should an object be placed from a convex lens? What is that? How fat? How fat means how large? How fat means how large? They are meaning how large. How fat should an object be placed from a convex lens of focal length 20 centimeter? So I am drawing a rough figure for that. A convex lens having focal length 20 centimeter. Having focal length 20 centimeter. That's a convex lens. So the focal length will be here, 20 centimeter, right? It will be like this. Okay. To obtain its real image at a distance of 30 centimeter from the lens. Okay. The image, the object is somewhere here. And the image is what? The image is at 30 centimeter from the lens. Okay, the image is 30 centimeter from the lens. Determine the height of the image if the object is 4 centimeter tall. Determine the height of the image HI if the object is 4 centimeter tall. So that's HO. HO is 4 centimeter. Find it. What do you have to find? HI. You have to find HI. If HO is 4 centimeter, that's one question, one part of question. There is another part of question. What is that? The first part of question is what? How fat should an object be placed? Oh, that's not fat. That's far. I thought it is given as magnification. It's not given as magnification. They are meaning how far, right? So how far should an object be placed from a convex lens of focal length to 20 centimeter? So you have to see the object distance. That's all. You have to see the object distance. Very simple. I thought to find magnification. So you don't have to find magnification. They are asking like that. How far should be the image? That should be for magnification. Right? So they are asking for you. You can do that. Just write. You can do that. Right? You can find it. You have to find two parameters from the question. You have to find two things from the question. The first one is where you are going to place the object. When you are getting the image at work, the image is at 30 centimeter from the lens. You are getting 30 centimeter, you are getting image at 30 centimeter. Where do you have to place the object? That's the first question. Then what will be the height of image? Very simple. Very simple. Very simple. You can draw a very rough image of that. A rough image of that. Then take the data out. Take the data out and use the equation. Put that into the equation. Find the calculation. Find the value. Yeah, lens formula. That's a lens, right? That's a lens. So you can use the lens formula. You take out the equation. You take out the data. That's the first step. That is the first step, right? What is the first step? It is given as focal length as 20 centimeter. Focal length is what? 20 centimeter. It's a convex length, so the focal length will be positive. And we have image distance at 30 centimeter. It is also positive. So the image will be on the right side. And you have to find U. How can you find U if you have the other two? If you have the other two, how can you find U? You can use lens formula. That will be 1 by f equal to. You can do your calculations. Don't need to look at here. If you don't have any clue, you can look at here. Otherwise, you can do that. 1 by f is equal to 1 by v minus 1 by u is the equation for lens formula. And I have the equation. Now I have the values 1 by 20 is equal to 1 by 30 minus 1 by u. Okay. I need a 1 by u. So I am taking this minus 1 by u to the other side. That will be plus 1 by u plus 1 by 20. Plus 1 by 20 is already there. Plus 1 by 20 is already there. Right? So this is 1 by u. And if you need 1 by u, you can bring this 1 by 20 to the other side. What will happen to this 1 by 20? You have already 1 by 30 there. If you are bringing 1 by 20 to the other side, what will happen? That will be minus 1 by 20. Careful on doing the conversions and bringing the terms to the other side of the equation. Always be careful. Always be careful. This will give you 1 by u. Now, what is 1 by u? You can cross multiply it. You can cross multiply it. If you are cross multiplying it, 20 into 1 is 20. Minus 30 into 1 will be 30. Divided by 30 into 20, you can write it like that. 30 into 20. Don't multiply it now. You may have a chance to cut it from with any other thing. You can have a chance. You may be getting a chance. So 1 by u is equal to 20 minus 30 minus 10. 20 minus 30. 30 minus 20 is 10. You can take a minus. So minus 10 divided by 30 into 20. Don't do the calculation now. You will get a chance to cut down something. You will get a chance to cut down something just like looking at it. Just looking at it, we will understand. We will get a chance to cut down something. So this is 1 by u. So what will be u? U will be 30 into 20 divided by minus 10. Now you will understand what I said. Now you will understand what I said. You have a 10 below. If you have 10 below, you can remove a 0 from it. You can remove a 0 from it. Now what is this? This is 30 into 2 divided by minus 1. 30 divided by 2. Sorry, 30 into 2. What is that? 60. 30 into 2, 60 divided by minus 1. 60 divided by minus 1 is minus 60. So you will be what? You will be minus 60 centimeter. You will be minus 60 centimeter. Did you understand the calculation? Calculations part? That's minus 60. Okay. Are we finished? No, we have another part of the question also. What is the other part of the question? You have to find HI. If you need HI, you have to find magnification. You have to find magnification. What is the equation for magnification of lens? HI by HO is there, but you cannot use that because magnification is not given. So what is the next equation? V by U. You have to find magnification first, then use that equation. Okay, so you have to use V by U. What is V? What is V? What is V? Yeah, what is V? V is 30 centimeter. 30 centimeter divided by U. Minus 60 minus 60. Okay, a 0 is gone. 3 by minus 6. Yes, 3 by minus 6 will be 1 by 2. Minus 1 by 2. That will be minus 1 by 2. That will be minus 1 by 2. Minus 1 by 2. That's magnification. You got the magnification now. Okay. Magnification has another equation also. What is the next equation for magnification? HI by HO. That's magnification. That's also magnification. So you can use that equation. You can use that equation. Can use that equation. M is HI by HO. So M is equal to what is HI? We don't know that. Divided by HO. What is HO? 4. HO is 4. I will use this equation here. I will use the value of equation here. What is M? What is M? What is M? M is minus 1 by 2. M is minus 1 by 2. So M is minus 1 by 2 is equal to HI. We don't know the value of HI divided by HO is what? HO is 4. How can you do this calculation? HI is equal to bring this 4 to the other side. Right? Bring this 4 to the other side. What you will get? Yes. So minus 1 by 2 is already there. So minus 1 by 2 into 4. What is this? Minus 1 by 2 into 4. Yeah, minus 4 by 2. That will be minus 4 by 2. Okay, I will write it. Minus 4 by 2. What is minus 4 by 2? No, minus 4 by 2. Minus 2. Minus 2 by 1 is what? Minus 2. Minus 2 by 1 is minus 2. So minus 4 by 2. You can close that. That will be minus 2. So HI is what? HI is minus 2 centimeter. HI is what? Minus 2 centimeter. Did you understand it, Jonathan? Did you understand to write this solution?
Yes, sir.
Okay. What about you? David, is the calculation okay? Calculations are okay. You're getting it done, yes? Okay. Okay. Sarah, what about you? Calculation is okay. Yes. If you need my assistance in calculation, just ask me. Okay. Then look at the next question. Our idea is to do the maximum questions today. The next question. 97. What is the question? 97. A real image 2 by 3rd of the size of an object is formed. So what is that data given? What is that data given? A real image 2/3 of the size of an object is formed by a convex lens. What is that first data given? Yes, the first data given is magnification. If they are talking about the size of the image in the question, they are talking about magnification. If they are talking about the size of the image in the question, they are talking about the magnification. So they have given the magnification and they are saying it is real. Then what will be the magnification value? No. If it is real, magnification will be negative. If it is real, magnification will be negative. So if it is real, magnification will be negative. And 2/3 of the size of the image. So what is magnification? 2/3. 2/3. Got it? 2/3 of size of image means magnification is 2/3. Twice the size of image. Twice the size of image. Magnification is -2. Right? -2. Thrice the size of image. Magnification is -3. Half of the size of the image. -1/2. Magnification is -1/2. You got it? So, formed by a convex lens when the object is at a distance of 12 centimeter from it. Convex lens. So, you have a convex lens and object is at where? Object is at 12 centimeter from it. Object is at 12 centimeter from it. 12 centimeter from it.
Sir,
Yeah.
sir, can I leave?
Yeah, okay, Jonathan. Okay. Find the focal
Okay.
length of the lens. Very simple.
Thank you, sir.
Yeah, okay, Jonathan. I am recording this session. I will send that.
Okay, sir.
Okay. How can you do this? Do the calculation by yourself. Do the calculation by yourself. No problem in it. Do the calculation by yourself. Very simple question. Listen. Because you how to understand that something. What is the value of u? Is it 12 centimeter? U is 12 centimeter. It will always be minus, right? Because object distance is always negative. Object distance is always negative. Object distance is always negative. Okay. How done such type of question before? Maybe in the mirror. Maybe in the mirror. How done such type of question? You don't have V, huh? But you have magnification and U. Okay, so you can find V from that. If you have V and U, you know. Multiplication of 8, you have to be able to use the unit. Always, write the unit. Okay? You should not forget the unit. You should not forget the unit. Right? Yeah. That's right. Okay. And doing the calculation, you can continue your numerical, you can continue your calculation if you are not done. I have the value of magnification and I know the equation of magnification. For length, it's V by U. Okay. And I have the value minus 2 by 3 will be V by, what is the value for U? U is minus 12 centimeter. Okay. So I can use the value here, that's minus 12. If I want this B, I can bring this 12 to the other side, right? I can bring this 12 to the other side. Then minus 12 into minus 2 by 3. There is already a minus 2 by 3. I am bringing this minus 12 to the other side. Then that will be divided by minus 12 will be into minus 12. Divided by minus 12 will be into minus 12. You got it? So minus 12 into minus 2. Minus into minus will be plus. So 12 into 2. What is that? 24. 24 divided by 3. What is B? 8. That's 8. 24 divided by 3 will be 8 centimeters. So that's B. You got it? Is the value correct? You got correct value for B? Yeah. No, that should not be minus 6. Why it can be minus 6? Where is the minus 9 in this? You are bringing this minus 12 to the other side, okay? And divided by minus 12 will be into minus 12, okay? Right, now your answer, okay? Calculation part is okay. That's final length, right? Okay. So you have a value of V now. You have a value of V now. If you have value of V, we can find F with the use of length formula. Length formula. You can use length formula. What is length formula? 1 by F is equal to 1 by V minus 1 by U. We can find 1 by F. The equation is 1 by V. What is 1 by V? 1 by 8 minus 1 by U. What is U? Minus 12. That's minus 12. Then that will be 1 by 8 minus into minus plus 1 by 12. Right? Minus into minus will be plus 1 by 12. Now you can cross multiply it. That will be 12 into 1, 12. Plus 8 into 1, 8. Divided by 12 into 8. Right? 12 into 1 plus 8 into 1 divided by 8 into 12. 8 into 12. Don't do the whole calculation. You will get a chance to cut something. 12 plus 8. What is 12 plus 8? 12 plus 8. What is that? 20. 20 divided by 8 into 12. That's 8 into 12. Okay. So that's 1 by F. That's 1 by F. Then what is F? F is 8 into 12 divided by 20. Take the reciprocal, you will get it. Take the reciprocal, you will get it. Now you can cut them with the number 2. You can cut them with 2. Do you know to cut this with this type of equation, right? Yeah? Or are you doing this 12 into 8, then dividing it that with 20? Are you doing like that, or you can cut it, right? Okay. Then 20 and 8 can be cut with 2. 20 by 2 will be 10. 8 by 2 will be 4. Right? Again we can cut it. Again we can cut it. 10 by 2 is 5. 12 by 2 is 6. Okay? And what is F? F is 4 into 6. 4 into 6 divided by 5. What is 4 into 6? 24, right? 24 divided by 5. That's your answer. 24 divided by 5 centimeters. Got it? Okay. 24 divided by 5 is the answer. What is 24 by 5? 24 by 5, only 4. Okay. 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 Yes, 4.8. So F is what? F is 4.8 centimeter. F is 4.8 centimeter. Got it? Everyone. Try it by yourself. Try it by yourself. Got it? Yeah. You always try to touch something. That will give you some time. If you are doing the whole calculation, you will lose some time. Don't do that. Are you finished with this one? With this one? Then look at the next question. The next question. State the laws of refraction of light. You can do that, right? Laws of refraction. Huh? Yeah. What is it, Kripa? Navin? Is it okay? Did something happen, Kripa? You got the answer right? What happened? Here is plus. That's the problem. So I guess minus plus. Others, read the next question. Others, read the next question. What is the next question? State the laws of refraction of light. You can see that, right? Explain the term absolute refractive index of a medium. What is absolute refractive index of a medium? N. And what is N? Sorry, it is not. It is absolute refractive index. What is absolute refractive index? What is absolute refractive index? Just N. What is N? It's a ratio. Ratio of C by V. If you need to study N, you just study this equation only. N is equal to C by V. Now convert this equation into words. You will get it. You will get it. N is equal to C by V. What is this? N is equal to C by V. And you can convert this equation into words. It is. It is. Ratio of speed of light in vacuum to the speed of light in medium. To the speed of light, not by. Ratio of speed of light in vacuum to the speed of light in medium. That's absolute refractive index. Got it? Okay. Then what is the next one? And write the expression to relate it with the speed of light in vacuum. What is that? Right? What is that expression? That's N is equal to C by V. So this is a very simple question. N is equal to C by V. Aaron, did you write it? You want to know? You should know what N1 is also the answer. Okay, you are writing the laws of refraction. Have they asked the laws of refraction? Did they ask the laws of refraction? Is the laws of refraction? Yes, good. Explain the laws of refraction. Okay, that should be part of the question. And the right extension. So there is three parts of the question, right? At first, they have asked us to write laws of refraction. There is two laws of refraction. First one is, you know the first one. Second one is sin I by sin R is equal to a constant. You can convert that into words. How will be that? Ratio of sin of angle of incidence to the sin of angle of refraction is a constant. Got it? Then N is equal to C by V is the equation. And next one. State the law. Okay. What is meant by power of a lens? What is meant by power of a lens? What is meant by power of a lens? Yeah, ability to bend light in simple form. Ability to bend light. That's the meaning of power of a lens. Or you can have this equation. P is equal to 1 by F. Define power from this equation. reciprocal of focal length. What is it, Aaron? What is it, Aaron? Oh, H1 is equal to no. Sin A by sin R is equal to a constant. That's second law. That's sin A by sin R is equal to a constant. That constant is H1. Got it? Like this. We are talking about laws of refraction. First one is what? Incident ray. What is the first one of refraction? Incident ray, normal, refracted ray, all lie on the same plane. What is second one? You should study this one. Sin A by sin R is equal to a constant. What is the name of this? It is called Snell's law. It is called Snell's law. This equation is called Snell's law. And define it. What is this? Ratio of sine of angle of incidence to the sine of angle of refraction is a constant. And this constant is N21. That constant is N21. Got it? That constant, the value of that constant is N21. Did you understand that? Okay. And that N21 can be written also like this. N21 is N2 by N1. That N21 is also N2 by N1. And it is also V1 by V2. Okay? Okay? Okay, then write its SI unit. What is the power? What is the SI unit of power? Give me the SI unit of power. Diopter. If you are writing diopter, that should be with the small letter. If you are writing the symbol, that should be capital. Okay? Okay. A student uses a lens of focal length 40 centimeter. So the focal length is given. What is the focal length? 40 centimeter. What is the focal length? 40 centimeter. And another of minus 20 centimeter. What is the meaning? He has used another lens having focal length minus 20 centimeter, right? Minus 20 centimeter. So I am taking the first focal length as f1 and second one as f2. Got it? Write the nature and power of each lens. Write the nature of power of each lens. Write the nature and power of each lens. So the first lens, I am taking the first lens. First lens. What is the nature of the first lens? Nature means what type of lens is that? F1 is what? F1 is 40 centimeter. If focal length is positive, what is that type of lens? If focal length is positive, what type of lens is that? You have to remember this figure. If light ray comes like this and it is converging at this point, so focal length will be to the right, so positive. So focal length positive means that will be a convex lens. That will be a convex lens. And the second one, it has a negative focal length, right? So the negative focal length will be what? That will be a concave lens. That will be a concave lens. Did you understand this? Did you understand this? That will be a concave lens. Okay? And write the nature and the power of each lens. You have to find the power also. You have to find the power also. How can you find the power of lens? You have to find the power also. How can you find the power of lens? Power of the first lens. How can you find power of first lens? Yes, power of first lens. Power of first lens. That's P1. You can call it as P1. What is the equation for P1? 100 by F. Why is that? Because the F is in centimeters. So 100 by F1. So P1 is equal to 100 divided by F1 is what? F1 is 40. F1 is 40. Now you can strike this 0. You can remove this 0. So P1 is what? 10 divided by 4. What is P1? 10 divided by 4. What is 10 divided by 4? 10 divided by 4 or 5 by 2. Oh, yeah, 5 by 2. What is 5 by 2? 10 divided by 4 is 5 by 2 or 5 by 2. What is 5 by 2? 2.5. What you will use as unit? What you will use as unit? Can you use the diopter as the unit? Huh? Can you use diopter as unit? Why is that? Huh? But you have converted it. You have converted it. Both of them, you have converted both of them, so you can use that. Right? If you are taking the equation 1 by f and giving this f as this 40 centimeter, that will not be in diameter. Right? Right? That will not be in diameter because the f should be in meter. In this equation, what is this equation? 100 by f. Now this equation is in centimeter. That means the meter has converted into centimeter, and below that, that's again centimeter. So that will be centimeter cut by centimeter. That will be in diopter. Okay, that will be in diopter. So 2.5 diopter. Power will be 2.5 diopter. That's power of first lens. Now power of second lens. What is power of second lens? What is power of second lens? P2. What is the equation for P2? That is 100 divided by F2. 100 divided by F2. And what is F2? 100 divided by minus 20. So you can cut 1 0 from it. You can cut 1 0 from it. That will be 10 divided by minus 2. What is the value of 10 divided by minus 2? That is minus 5. Minus 5 diopter is the power of second lens. You got it? Minus 5 diopter is the power for second lens. Did you understand that? That's a very simple question, right? That's a very simple question. Okay. Did we do question number 108? Did we do question number 108? Huh? Okay, then we are doing question number 108. Page number 23, 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 question number 108. 108. That question looks like it is a very large question, but that's a case study question. What is that? The ability of a medium to refract light is expressed in terms of its optical density. You know that, right? Optical density has a definite connotation. What is connotation? Connotation means a definite meaning, its own meaning. It is not the same as mass density, right? That's connotation means. It's not mass density. And on comparing two media, the one with the larger refractive index is optically denser medium than the other. One with the larger refractive index is optically denser. You know that. The other medium with the lower refractive index is optically rarer. You know that, right? Larger refractive index is optically denser. Low refractive index is optically rarer. You know that, right? Also, the speed of light through a given medium is inversely proportional to the optical density. What is that? Speed of light through a medium is inversely proportional to optical density. What is the meaning of this? What is the meaning of this? Have you seen this type of representation of relations like this? This is speed inversely proportional to refractive index. Okay? As refractive index increases, what will happen to speed? It is inversely proportional. So if refractive index increases, speed will decrease. Did you understand? If refractive index increases, speed will decrease. Got it? If refractive index increases, speed will decrease. Okay? What is the meaning of that? Yeah, inversely proportional. If refractive index increases or optically denser, refractive index is high, optically denser, speed will be decreasing. Speed will be decreasing. That's all in the question. And the first question is determine the speed of light in diamond. Diamond is a medium. If the refractive index of diamond with respect to vacuum is 2.42, it is given. Refractive index of diamond. Okay, I am taking it as D. ND. Refractive index of diamond with respect to vacuum. What is that? I don't have to take it as ND then. Refractive index of diamond with respect to vacuum is what? Refractive, yeah. Yeah, that's C by V. That's when it is absolute refractive index. That's not N21, that's not N12, right? That's absolute refractive index of diamond. So I am taking it as ND. Is that okay? ND. ND is 2.4. 2.4. Speed of light in vacuum is given. Speed of light can be written as C, right? So C is given as 3 into 10 raised to 8 meter per second. Speed is given as 3 into 10 raised to 8 meter per second in vacuum. And what is speed of light in diamond? How can you find speed of light in diamond? With what equation? With what equation you can find it? Refractive index of diamond is given and C is also given in the question. So we have the equation for refractive index. What is that? C by V. How can you find the value of V? How can you find value of V? V is asked in the question. What is the speed of light in diamond? That is the question. So you can find V, just bring this V to the other side. V is C by N. That's V. C by N. That's V. So what is C? C is 3 into 10 raised to 8 divided by what is N? Yes, N is what? N is 2.42. N is 2.42. How can you do this calculation? How can you do this calculation? 3 divided by 2.42 into 10 raised to 8. Do you know how to use this 10 raised to 8 and give the zeros to 3? Do you know the calculation part like that? Do you know what is this 10 raised to 8? 8 zeros. That much zeros. Okay. If I am giving 2, 3, no, I will write it like this. 3 by 2.4. You can do it. This will be okay. 2 by 4, 2.3 by 2.42. How can we do this calculation? Yes. Multiply that with 100 on both the numerator and denominator. Now you will get 300 divided by 242. What is 300 divided by 242? That's 1, 242, 8, 5, 0. Right? That's 58. Then 580. 580. That must be 2, right? So 2. So 242 into 2 will be 482. 484. So 2. 2 into 248 is 484. That will be enough. That will be enough. 1.2 will be enough. So 3 by 2.42 is what? That's 1.2. So 1.2 into 10 raised to 8 will be the answer. You don't have to do nothing on this 10 raised to 8. You don't have to do nothing on this 10 raised to 8. Just divide 3 with this 2.42 and find the answer. And write that answer here. Then 10 raised to 8. Take the 10 raised to 8 and write it down. So that will be the speed of light in diameter. That will be the speed of light in diameter. Did you understand that? That will be the speed of light in diameter. Okay, we have done the first question. And now the second one. What is the second question? Refractive index of glass, water, and carbon disulfide are 1.5, 1.33, 1.62 respectively. What is the data given? Are you finished with this question? Are you finished with this question, Ravi? You should tell me if you haven't finished it. I will not move to the next question if you haven't finished it. I will wait for you. Okay, can I move to the next question? Then 109. Sorry, question number B. Right. Refractive indices. Refractive indices for glass, water, and carbon disulfide. Glass. What is that? Water, carbon disulfide, or you can simply write carbon disulfide. That's CS2, carbon disulfide. Okay. If a ray of light is incident in this media at the same angle, it is given. Refractive indices are given. What is refractive index of glass? I can take it as Mg, right? You can take it as Mg. Mg is 1.5. 1.5. N. What is this? N. Water. Refractive index of water. So I am taking it as Nw. What is Nw? That's 1.33. 1.33. What is refractive index of carbon disulfide? I am taking it as Nc. What is that? 1.62. That's 1.62 respectively. If a ray of light is incident in this media at the same angle theta, then write the increasing order of the angle of refraction in this media. Right? Increasing order of angle of refraction in this media. So the angle of refraction in this media is taken as Rg. Okay. In this, I can take it as Rw, and in this, I can take it as Rc, or you can take it as R1, R2, R3, no problem. How can you write this in the form of refractive index? Sorry, angle of refraction, increasing order of angle of refraction. How can you find this? You have an idea. What is that idea? If a light ray is coming like this, there will be a normal line like this. That's angle of incidence, and this is the supposed to be path. This is the original path of the incident, right? And it will not go like this if this is rarer to denser. If it is rarer to denser, if it is rarer to denser, it will bend towards the normal. It will bend towards the normal. Now, okay. Now we have to find the which is bigger in it. Which is bigger in it. What will happen if rarer to denser? It will bend towards the normal, right? Bend towards the normal means angle of refraction is decreasing. Bend towards normal is angle of refraction is decreasing. Okay? Okay? If it is more denser, the angle will be lesser and lesser. If it is more denser, the angle will be lesser and lesser and lesser. If it is more rarer, the angle will be greater and greater and greater. Did you get it? If it is more denser, what will happen if a light ray is traveling from rarer to denser? It will bend towards. If it is more denser, it will bend more towards denser. It will bend more towards normal. Right? It will bend more towards normal. Did you understand that? More towards normal. So, which is the greater one in it? Mg, Nw, Nc. Which is the greater one? Nc is the greater one, right? Nc is greater than Nw, sorry, Mg, and Mg is greater than Nw. This is the order of refractive indices. If the order of refractive indices are this like this is more denser, this is less denser, and this is the least denser. Okay? If it is denser, angle of refraction will be lesser. Density increases, angle of refraction decreases. Density increases, angle of refraction decreases. So I will write RC here, RG here, RW here. Which is greater, which has density higher, NC has greater density. So the RC will be what? RC will be least one. Huh? RC will be least. NG is greater than NW. That means angle of refraction in NG will be lesser than angle of refraction in water. So this will be our answer. This will be our answer. Did you understand that? This question? Did you understand the question? The only idea you have to remember is what? Optical density higher, it is bending more towards normal. Bending more towards normal means refractive index will be decreased. Bending more towards normal means refractive index decreases. As you can write it. You can write it. I will give you the note for that. You can write it. You can write it. Write it. One minute, please. 1 minute, please. In the solution part, it is not like that I have told you. In the solution paper, it's not like I have told you. So you don't write it now. You don't write it now. I will check again. This is as per my knowledge. I will check again. If there is any correction, I will make that correction and we will discuss that question later. Okay. In the solution part, it is not like that. Right? I think this is correct. I think this is correct. But in the solution part, it is not like this. The solution part, the solution PDF, it is not like this. I will check it again and will correct if there is any mistake. I will correct if there is any mistake. So you don't write this now. You don't have to write this now. Just leave it. Just leave this question. Question number B. Okay? Leave question number B. After that, if there is anything, I will make that in the next session. I will make that correct in the next session. In my opinion, in my knowledge, it is like this. Did you understand the idea that I have just conveyed you? Then look at the next question. Question number 3 in it. Question number 3 in it. The speed of light in glass is given and in water is also given. The speed of light in glass and water is given. Which one of the two is optically denser and why? That's the question. Okay. So the question number 3, Roman letter 3. Roman letter 3. Question Roman letter 3. What is that? Speed of light in glass. I can take it as Vg, right? I can take it as Vg, speed of light in glass. So Vg. That's 2 into 10 raised to 8. 2 into 10 raised to 8 meter per second. Got it? Okay. Then in water, that's 2.25. In water, I'm taking it as VW. 2.25 into 10 raised to 8 meter per second. In water, it is 2.25 into 10 raised to 8 meter per second. Which one of the two is optically denser and why? Which one of the two is optically denser? Which is optically denser? Which is optically denser? This is speed of light in that medium. If speed of light in that medium is high, it is optically rarer, right? It is optically rarer. It has low density. It has low optical density. If it has low optical density, light can travel fast, right? If there is a medium like this, if you have a medium like this, light is traveling from this medium to the next medium. Light is traveling from this medium to next medium. This is air. This is water. This is air and this is water. Velocity of light in air is v1. Velocity of light in water is v2. Which is optically denser? Which is denser, air or that one? Water. So if air is N1 and water is N2, which is greater? N2. N2 will be greater. That means if refractive index is high, speed will be low. If refractive index is high, speed will be low. Okay. If refractive index is high, that will be denser medium. If refractive index is low, that will be rarer medium. So what is the question? Question is, which of these is optically denser? Which of these is optically denser? Glass or water? Yeah. No. Which is optically denser? Glass or water? Glass. Glass is optically denser because it has less speed. It shows less speed of light through it. Light is slowing down when it enters glass. Light is slowing down when it enters glass. Right? That means glass has larger refractive index and it is greater density. It is having greater density. So you can write it. You can write it. Answer A. Answer A. You write the two values here. You write the two values. VG and VW. Write the two values VG and VW. Write two values VG and VW. Write two values VG and VW. VG and VW. VG and VW. Got it? VG and VW. And right. Glass is optically denser. Glass is optically denser. Glass is optically denser. Glass is optically denser. Because speed of light through glass is lesser. Because speed of light through glass is lesser. 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 Did you understand that? Speed of light through glass is lesser. Now we have to make a point. We have to make a point. Refractive index increases. when you have to make a point, it will be like this. When refractive index increases, when refractive index increases, optical density increases. What is happening to optical density? Optical density increases. Optical density increases. If optical density increases, velocity of light decreases. Did you understand that? So you have to make this as a point. Velocity of light decreases. Velocity of light decreases. Velocity of light decreases. Did you understand the point? Refractive index increases. Even refractive index increases, optical density increases. If optical density increases, velocity of light decreases. Did you understand that point? If you have that point, you can answer this question. Or this type of every question. Every question that is having this type of concepts. Okay. Then the next one. B. A ray of light is incident normally at the water glass interface when it enters a thick glass container filled with water. Thick glass container filled with water. What will happen to the path of ray after entering the glass? What will happen to path of light ray when entering the glass? When entering the glass, what will happen to the path of the light ray? What will happen to the path of the light? Read the question again. Read the question again. Ray of light is incident normally at the water glass interface. Light is incident normally at the water glass interface. What will happen? Is it bending? Will it bend? Yeah. If a ray of light is entering, if a ray of light is entering normally, then it will not bend. Then it will not bend. It will pass through the medium without any refraction. Only the light ray with an angle, yes. Only the light ray with an angle will bend. If it is normal, if the light ray, this is light ray. If the light ray is coming normal to the surface, it cannot bend. You understand that? The answer part is again wrong. The answer part is again wrong. This is actually, the answer part is wrong, in my opinion. If it is normal, it cannot bend. That's your knowledge also, right? Then we can have that answer. Just write the answer. Write the answer. When the light ray is, what is it? Make the question of a current, otherwise you will not be confused. Make the question of a current. When the light ray enters a medium normally, when the light ray enters a medium normally, when the light ray enters a medium normally, when the light ray enters a medium normally from another medium, it will pass through the medium without refraction. 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 Then underline the term normally. Then underline the term normally. Underline the term normally. Normal means with the 90. Normal means with the 90 degree. Did you understand that? Okay. Should I show you that with an equation? Do you want to understand that with the help of an equation? Or can you help me this idea with an equation? If it is coming normally, it will not bend. Can you prove that with the equation? Can you prove that with the equation? Huh? You can, that's very simple. What is Snell's law? Sin I by sin R is equal to sin I by sin R is equal to a constant, right? Into one, right? Huh? What is sin I now? Sin I is sin 90. If sin 90 is sin 90 and the refractive index, there is a refractive index, there will also be a refractive index here. If sin 90 is 1, what that will be 1 divided by sin R. What is sin R? Sin R will be what? Sin R will be also 90. Sin R will be also sin 90. So that will be 1 by 1. Then what is the meaning of that? You cannot have the Snell's law though. There is no ratio of sin A by sin R. Sin A by sin R is not good. What is sin R? No. Not like this. Not like this. Not like this. Not like this. Not at all like this. Sin A by sin R is equal to n to 1, right? What is I and R here? What is the value of I and R here? What is the value of I and R here? Hello? And then okay, what is the value of I here? No, that's not 90. No, I is not 90. 90 here is normally. Normally means light ray is perpendicular to the surface, not the I. It is not I. It is not I. What is I? Define I. I is the angle between light ray and normal. Now what is I? 0. I is 0. What is R? 0. R is 0. So sin 0 divided by sin 0. What is that? 0. That means there is no Snell's law here. No Snell's law here. No bending. Okay. So the light ray is coming normal to the surface. If the light ray is coming normal to the surface, there is no Snell's law. Light ray will not bend. Did you understand that? Okay. Did you write that? Did you write it? Okay, then the or question. Look at the or question. The absolute refractive indices of water and glass are given. Okay, absolute refractive index of glass. I am taking that as absolute refractive index of glass. What is the given value? Absolute refractive index of water and glass. So water is first. Absolute refractive index of water is given. What is that value? 4 by 3. And absolute refractive index of glass, what is that? That's 3 by 2. 3 by 2 respectively. 3 by 2 respectively. If the speed of light in glass is 2 into 10 raised to 80 meter per second. Speed of light in what? Speed of light in glass. That's Vg, right? Vg is given. What is the value of Vg? Vg is 2 into 10 raised to 8. 2 into 10 raised to 8 meter per second. Okay, it is given. Find the speed of light in vacuum and water. Speed of light in vacuum and water. Speed of light in vacuum is what? Speed of light in vacuum is c. Okay, and speed of light in water is Vw. They are asked you to find the c and Vw. How can you do the value of? How can you find the values? This c and Vw. Yeah. N is what? N is equal to C by B. Right? You can use both these N. No problem. You will get the same answer. You will get the same answer. You can use the NW. What is NW? That will be 4 by 3 is equal to C by. No. You cannot use NW because NW, VW is not given. So you can use NG. You can use mg. Mg is what? Refractive index of glass will be what? C divided by velocity in glass. Did you understand this? Huh? Huh? Refractive index of glass will be speed of light in vacuum divided by speed of light in glass. Glass is the medium. Okay. So Ng is 3 by 2. Ng is 3 by 2. 3 by 2 is equal to C by Vg. What is Vg? Vg is what? Vg is 2 into 10 raised to 8. So what is C? What is C? You can bring this term to the other side. Then that will be 3 by 2 is already there. This is on denominator. If you are bringing it, that will be into 2 into 10 raised to 8. Then what is the next step? What will happen here? No, see, 2 can be cut from this, right? There is a 2 on top and 2 on bottom. You can cut it. So what is the value of C? What is the value of C? Value of C is 3 into 10 raised to 8 meter per second. Simple. That's it. Okay. Then how can you find this value of VW? How can you find value of VW? NW is what? NW will be C divided by VW. NW will be C divided by VW. Or just look at the NW is C by VW, right? Now, NW is given as 4 by 3 is equal to C. C is 3 into 10 raised to 8 now, divided by VW. You can find VW from this. How can you find VW from this? Bring VW to the other side, then that will be 4 by 3 into VW is equal to 3 into 10 raised to 8, right? Right. Then what is VW? You can bring the 4 by 3 to the other side. Huh? You can bring 4 by 3 to the other side. There is already 3 raised to 8 there. There is already 3 raised to 8, 3 into 10 raised to 8 there. If you are bringing 3 to the other side, that will be into 3. Yeah, that will be into 3. If you are bringing 4 to the other side, that will be by 3. Sorry, by 4. Yeah. And what will be this? 3 into 3. That's 9. 9 into 10 raised to 8 divided by 4. 9 into 10 raised to 8 divided by 4. Now what is 9 by 4? 9 by 4. What is 9 by 4? Yeah, 9 by 4 is 1, 2. 2, 4, 8, 1 or 2. 2.2, right? So 9 by 4 is 2.2, right? Okay, that will be 2.2. So 2.2 into 10 raised to 8. That's VW. That's VW. Velocity of light in water. Velocity of light in water. That's VW. Velocity of light in water. Did you got it? Velocity of light in water. So we have completed the question 108. We have completed the question 108. We have completed the question 108. Did you understand that calculation? Huh? Okay, everyone. Then look at the question 109. 109. We will get time to complete that. Maybe 1 or 2 questions. 1 or 2 sub questions from it. Many optical instruments consist of a number of lenses. They are combined to increase the magnification and the sharpness. That's, you have to call it as, you have to read it as sharpness. So, sharpness of the image. The net power of the lenses placed in contact is given by the algebraic sum of the powers of the individual lenses, P1 plus P2 plus P3, etc. This is also termed as simple additive property of the power of lens, widely used to design lens system of camera, microscope, and telescope. This lens system can have a combination of convex lens and concave lens. That's the case. Okay. Now the question: what is the nature of the combination of convex lens of power? You have to read it as convex lens of power. Convex lens of power plus 4 diopter and concave lens of power minus 2 diopter. Okay. Okay. What is that? You are taking combination of lenses. Combination of lenses. What is the first lens you are taking? You are taking a convex lens. That is having a power plus 4p. I am taking it as p1. Is that okay? Okay. Now I am taking a concave lens. What is the power of that concave lens? That concave lens has a power minus 2d. Okay. Now, what is the nature of the combination? So you have to find the combination power of the combination. You have to find the power of combination. What will be power of combination? Yeah, P is equal to P1 plus P2. What is P1? 4. Plus P2 is what? Minus 2D. Right? That's minus 2D. Okay? So what will be that? That's 4D plus minus 2D. What is that? 4D plus minus 2D. That will be 2D plus 2D. So that's the combination of power. Power of the combination. Right? Power of the combination. Now tell me, what is the type of the lens? Yeah. This is what? This is positive. Power is positive. Power positive means it's a convex lens. You got it? If it is a convex lens, the nature is converging lens. Nature is converging lens. If that's a, if that is what? If that is a positive power, that will be a convex lens. If that's a convex lens, you can call it as converging lens. Did you understand it? Okay. Then what is the second one? Calculate the focal length of a lens of power minus 2.5d. The power is given. The power is given as minus 2.5d. You have to calculate the focal length. What is the equation? P is equal to 100 divided by f is the equation. You can find it in centimeter, no problem. Okay? Okay, then you have to find f. You can bring this f to the other side. 100 divided by p is here. 100 divided by p. What is p? Minus 2.5. Minus 2.5. How can you do this? 100 divided by minus 2.5. Just multiply that with the 10. Here and here. So that will be 1000 divided by 25. How can you find 1000 divided by 25? You don't have to do the calculation, you can cut it. 25 divided by 25 is 1. 100 divided by 25 is 4. So 4 and a 0. So 40. What is the focal length? That will be 40 centimeter. Focal length will be. Yeah. 100 into, yeah, there is a minus here. No. Okay. This is the next question, right? So the power is negative. So if power is negative, focal length is also negative. If power is negative, focal length also is negative. So that will be minus 40 centimeter. If power is negative, focal length also will be negative. Focal length also will be negative. Then focal length is negative, minus 40 centimeter. Did you get it? Okay, good. Then the next one, draw a ray diagram to show the nature and position of the image formed by a convex lens of power 1 diopter. Power 1 diopter. What if the power is 1 diopter? Power is 1 diopter. P is equal to 100 divided by F. Then F is equal to 100 divided by P. What is 100 divided by P? That's 1. That means 100 centimeter.
That's 0.1.
Is it 0.1? Oh yeah, that's 0.1. Then our calculation will be different. If power is given as 0.1, if power is given as 0.1 diopter, Then the equation is what? P is equal to 100 divided by F. F is 100 divided by P. 100 divided by P is 0.1. You have to multiply that with 10. You have to multiply that with 10 on top and 10 on bottom. Then that will be 1000. 1000 centimeter. 1000 centimeter. Focal length will be 1000 centimeter. With everything in centimeter, that will be like this. So that will be focal length. 1000 centimeter. You got it? That 1000 centimeter. So, what is the question? What is the question? Calculate the focal length of lens of power minus 2.5 and see. Okay, when the object is expected distance 20 centimeter from its optical center. Okay, you have to draw the figure when an object is placed at the distance of 20 centimeter from its optic center. So you can draw a line here and a point here that is the optical center, and 2 centimeter up, 2 centimeter down. You will have a lens like this. Okay, then take 2 centimeter here, that will be f1. Another 2 centimeter here, that is to f1. And mark this f1 here 2 centimeter and here also 2 centimeter. Then mark this f2 as 1000 centimeter. Or what is 1000 centimeter? 1000 centimeter. 1000 centimeter is how much meter divided by 100. That will be 10 meter. Okay. 4000 centimeter or 10 meter. 1000 centimeter or 10 meter. And you have marked it. When the object is placed at the distance of 20 centimeter from its optic center. 20 centimeter from its optic center. That means the focal length is what? Focal length is 1000 centimeter. Focal length is 1000 centimeter. And the object is placed between F1 and O. If the object is placed between F1 and O, where will be the image formed? Where will be the image formed? First line will be like this. First line will be like this. And it will pass through F2 like this. Second line will be like this. And you can extend them. If you are extending the light rays, you will get a point here. At that point, you will get an image. If you understand that, this will be the diagram. Why did you understand why you take the omega this particular figure? Why you draw this particular figure? Our focal length is given. Our focal length is 1000 centimeter, right? Our focal length is 1000 centimeter. If our focal length is 1000 centimeter, then if our focal length is 1000 centimeter, then what is that? Object is placed at 20 centimeter. That means focal length is 1000 centimeter. And object is between F1 and O. Object is between F1 and O. The image will be on the same side. It will be a virtual image, larger image, erect image on the same side. Okay. Okay, we have discussed we have completed the question number 108. That will be enough. Sorry, 109. That will be enough for now. We will do the rest of the numerical questions in the next class, next session. I think you are now ready to attend a school level exam. This is actually previous year questions. Now, I think you will be able to, you are ready to attend a school level exam. Are you? Right? Okay. And study well. Study well. If you have any doubts regarding any topics or any numericals, just message me, take a photo of that particular question and message me, I will explain. Okay? So we have a mock test also on Friday. We have to study that. And we will try to set a revision session before your exam also. Another revision session before your exam also. Okay? Are you ready to appear for that school level exam now? You will score the full mark, right? Okay. You can leave. If you have completed it, you can leave. Thank you. See you later. Take standard below from the there is the standard on the top of the printer. There will be a standard on the top of the printer. See it. I see it. Yeah, do it. Sorry. See you later.